Hi everyone, welcome to Cloud on Air. My name is Jay Jenkins and I'm a customer engineer based in Singapore. In this session, Malcolm Holden is going to take you through Google Cloud Platform from beginning to end, covering everything from G Suite, compute, storage, analytics, and machine learning. Malcolm Holden has over 30 years of experience in IT, and he's going to bring that experience to this session. I'd also like to remind you that any time you can ask a question below, and we have technical experts standing by ready to help. Toward the end of the session, you'll also have an opportunity to provide some feedback, so please do so we can make sure that this session is valuable to you moving forward. And with that, I'll transfer it to Australia to Malcolm. Take it away, Malcolm.
Thanks, Jay. Good afternoon, everybody, and thanks for joining us for the Google Cloud On Air webinar series. For the next 40 minutes, it's my privilege to introduce you to the components of the Google Cloud Platform and take you through what those services are and how you might possibly use them in your organization to leverage the capabilities of the Cloud Platform. As Jay mentioned, I'm a customer engineer based out of Google's Sydney office, and I work with customers across Australia and New Zealand to help them on their journey to the Google Cloud Platform. So my goal today is really to, as I mentioned, introduce you to the services provided in the Google Cloud Platform, what it has to offer. I'm not really going to be able to dive down deeply into a lot of those services because of the time. Fortunately, there are some other webinars this week which will be able to go down deeper into some of the technologies. But as you'll see, the platform is very broad, so to cover it all very deeply will take a considerable amount of time. But what I'm hoping to do is cover at a high level everything from infrastructure to big data, from collaboration through to machine learning, and talk about how those services play together and how you can leverage them in your organizations. But before I do that, I'm going to take a little bit of a step back and do a bit of a history lesson. So in the beginning, Google started with the vision of organizing the world's information and making it readily accessible or universally accessible and useful. And as part of that, we created Google Search. So a lot of you will be very familiar with this user interface, and I'm sure, like me, you use it every day at work and at home. But essentially, when we started, we had a lot of problems we needed to address. How do we crawl that internet of things? How do we crawl the data on the internet? How do we ingest the data, understand the data, and process that so it's in an indexable way or indexable format that we can serve back up to customers, allowing them to do their queries. So as part of that, we've developed a range of both technology and software services that help us address that. And it's those services and those technology stacks and the network topology that we now make available as part of the Google Cloud Platform for you to run your workloads and for you to leverage those capabilities in your own organizations. So back in 2002, a billion was a big number. Perhaps a billion still is a big number. There was about 1 billion pages back then that needed to be indexed. As you know, the internet's grown significantly since then. There's a lot more data out there. So the problem is exacerbated. So we've needed to scale over the last 18 years to address that. I mentioned 1 billion was a big number. Today, 1 billion is still a big number, and it's about the number of users we have using search every day. It's also the amount of users we have using other products within the Google portfolio. So you can see Google Play Store, Chrome, Android, YouTube, Gmail, and of course Google Cloud Platform itself. Each of these technologies is servicing the capabilities to over 1 billion users, and they all run on the Google infrastructure. That unique blend of our technology, our network layers, and our particular software stacks to provide that capabilities to our own products and now to your customers, and in your products to your customers. But our Google platform is expanding, and you can see from this slide we've got a heavy investment in the Google Cloud Platform infrastructure over this year, in the year 2017. This slide is showing the number of regions that we have deployed around the world, where Google infrastructure is sitting and ready to be used in both points of presence and regions. Within regions, we have zones, and you can see here we're expanding significantly, particularly in the Japan and Asia Pacific region. So you can see we have the region in Tokyo, the region in Singapore, regions soon to come online in Sydney and elsewhere in India and Asia Pacific. But it's not just the regions and the zones that you're able to make use of, it's also the Google network backbone. So we have thousands of miles of dark fiber across the world that provide a very high performant network between our locations and between your own data centers into Google. At any one time, it's estimated that our network backbone carries about a third of internet traffic. So this is really important. We have our own infrastructure between our regions. Once you're on the Google network, you typically stay on that network, wherever you need to go, and it makes processing data very performant. Our network topology is very fast. It's not just about infrastructure and networking, it's also about the software solution engineering labs. So starting in 2002 with Google File System, moving up to things like MapReduce, Dremel, Bigtable, Flume, Spanner, and things like TensorFlow and Kubernetes. So these are all technologies that have their roots in our research division. To address particular needs of Google, we've implemented those as part of our platform to deliver certain functionality. And for a lot of these, we actually make them available as open source, so you can leverage them externally as well. When people come and talk to you, and I'm sure perhaps you've seen this slide, you'll see this massive number of blue hexagons with strange icons on them, roughly grouped in things like management tools and machine learning and compute. For some, this can be a little bit daunting, a little bit confusing to understand. And in fact, even if you go to the Google Cloud website, the question is, where do I start? And that's really my goal today, is to try and help you on that journey, to make sense of a slide like this and to simplify it down to some very basic building blocks that we all need when we're looking at our own compute workloads. I'm going to do that by really sticking to the agenda on the screen now. I'm going to start talking about computing, I'll move into networking, I'll talk about storage, big data, administration, development, and finally, because this is a Google Cloud Platform presentation, I'm going to talk about machine learning, which is very important to us all here at Google. For some of these, I'm not going to drill deep into the underlying technologies or the services provided, because they're going to be covered in other sessions this week On Air, but also because of time available. Each of those little blue hexagons can probably justify a day, a half day, a day, a week even, to really drill down under the covers. So we're going to keep it simple at a high level and provide you with enough information that you can start on your own journey and start utilizing some of the Google Cloud Platform capabilities to deliver value and benefit in your applications. So starting with computing, or how do we do things on the Google Cloud Platform? And really there's three things we want to talk about here. The first one's virtual machines. So that is, I have something running on my on-premise or on another cloud or somewhere else, and I want to bring that to Google Cloud. Or containers. Containers is a very hot topic at the moment for application development and abstracting, providing an abstraction layer around that application development. And I'll talk about how containers can be used on the Google Cloud Platform. And finally, I'll talk about serverless computing, which is all about organizations that don't really want to worry about the underlying infrastructure or operating system. They want to focus on applications and on functions themselves, and not worry about the underlying technology. So I'm going to talk a little bit about that as well. So let's start with computing, virtual machines. So virtual machines are exactly that. It's a virtual server, a virtual machine running on the Google Cloud Platform. When you create these, you use a thing called Google Cloud Compute Engine. And this enables you to construct a virtual machine with a number of virtual processors that meet your requirement from 1 to 64. You can assign memory onto that virtual machine, so anywhere from 0.6 of a gigabyte up to 416 gigabytes. There is a ratio between memory and CPUs. It's a little bit loose, but essentially you can vary that a little bit. For your computer instances, you may want to put some disk on there. You can add persistent disk, you can add solid state drives, you can add RAM disks. And you can use our pre-configured images. So a Compute Engine comes with various Unix flavors. So you may want to spin up a Debian or a Ubuntu or a Red Hat image, or maybe even a Windows image. And you can do that out of the box. Or you may want to come with your own image. Maybe you want to run a different flavor, a different distribution of Linux, or perhaps a bespoke operating environment. You can bring that along and start that up as well. You can then take our images, the default Debians, Ubuntus, etc., modify them, add your own bits and pieces of them, to them and make your own templates, which then you can use to kind of kickstart future compute engine instances. The really good thing here is that they spin up very fast. So we like to mention, think of them starting up in tens of seconds. So not minutes, but within tens of seconds. So typically that can be, 10 seconds, you'll have a system up, 20 seconds, etc. So these are a really great way of, getting a server up in the Google Cloud Platform and doing what you want with it. But sometimes though, you want to kickstart that a little bit further. So you could take Debian and Ubuntu and have an image up there very quickly. But you may want to have a LAMP server, or you may want to have a WordPress server, or a Drupal server, or a Jenkins server, or a particular system of servers up there to help service your needs. So Google provides a functionality called Cloud Launcher, and up there we have a number of common patterns that organizations typically use, like LAMP, WordPress, Drupal. And you can go to Cloud Launcher and say, well, I want a WordPress server, please, and it would be deployed. It will deploy the OS, the WordPress the WordPress application, and you're up and running. It kickstarts you along that journey. We don't manage that. It's your responsibility to manage, but it helps you accelerate the time needed to get those kind of servers up and running. They can be single servers or groups of servers. If you go to Cloud Launcher, you'll see a library of these services up there. So that's virtual machines. The next one along is all about containers, and this is about abstracting our application development down into that container world. So rather than focusing on virtual machines, we're now focusing on an abstraction layer called a container. And inside Google Cloud Platform, this is provided using Google Cloud Container Engine, which is essentially managed Kubernetes. And as the developer advocate Terence Ryan in the US calls it, Kubernetes. So what exactly is Kubernetes? So Kubernetes is essentially an open source technology, software technology that has come out of our Google Labs. And it provides container orchestration. So this is orchestrating your containers that may work together in complex systems. So it enables you to run a large number of containers and manage that very effectively and very efficiently across the implementation. So as an example, I might have a 3-layer type application here with a data backend, an API layer in the middle for processing, and a front end. And within those, I have a number of containers running to provide that certain functionality. I treat them as a system. I treat them as a single unit, really. And Kubernetes helps me manage that so that if one server goes down at the API layer, and I've specified I always need to have 4, it will automatically start another one up. So it manages and monitors that system running. Now, you can run Kubernetes on premise if you like, or in fact, you can run it anywhere you like, on your laptop even. It's an open source technology. But to do it, you really need to do a couple of things. If you're running it off cloud, so on-prem, you need to build up the machines, install the operating systems, maybe install Kubernetes, or you will need to install Kubernetes on top of it. Define the networking topology that's going to tie all these servers together. You then may want to put in some DNS registry, a service discovery service, maybe some logging and some monitoring, because those things are important. So, it's reasonably complex to have this up and running on premise, and then you've got to manage it from a software update perspective, make sure the operating system is continually patched. The alternative is to use Google Cloud Platform. So as I mentioned, in Google Cloud Platform, we have let me get to the next slide. In Google Cloud Platform, rather than building everything yourself, you go into the Google Cloud Console, which is our browser-based tool for managing your Google Cloud environment. You click on Container Engine, and you click that button that says Create a Container Cluster, and the cluster comes up. You specify how many servers, nodes, etc. you want, and up it comes. Much more simple to use, and enables you to accelerate, that journey once again. So as I mentioned, Kubernetes is available on the Google Cloud Platform as Container Engine. We include some smart defaults there around monitoring and logging and DNS and service discovery, etc. And the good thing here, it's auto-scaling. So you provide the parameters under which you want that scaling to occur, and we do the rest. We manage that for you. The other way of doing containers inside Google Cloud Platform is using App Engine Flexible. So in Google Cloud Platform, there's 2 versions of App Engine. There's App Engine Flexible and App Engine Standard. So I'm talking here particularly about App Engine Flexible. App Engine Flexible really is based on Docker under the covers. If you want to bring your own Docker file, you can bring that into App Engine Flexible, flick a bit that says, runtime equals custom, and it will start up and run that container for you, that Docker container for you, and provide you with an endpoint that you can then call that container or access that container through, and it will allow you to auto scale. So you get all those good things out of the box. So it'll auto scale from your one instance up to however many instances you need to cover your particular performance and your particular load. So that's containers. There are a couple of tools on the platform that help you with containers. So the first one is Container Registry. And this is a container image storage. So you have your images, you can store them in the registry, register them in the registry, strangely enough, and have them available for deployment inside the Google Cloud or potentially inside App Engine, or even running Docker on your laptop or on premise. So quite a lot of developers will use the registry to store their Docker images. They can deploy to production, or they can deploy into the cloud, or they can do development on their machines and in their environments using their own Docker containers. The other tool there is Container Builder. So once your container layer or your system of containers becomes more complex, you may want to use something like Container Builder to build out what those interactions are, and it enables you to tie that back into any continuous integration type product you may have in the back end. So a couple of tools to make that a bit easier if you're going down the container route. So while we're there, we're going to talk about App Engine Flexible. I've mentioned that we can run App Engine Flexible in a Docker, in a custom Docker way, but typically we provide some runtimes to run inside App Engine Flexible. This is where you're not bringing your own Docker file, you're going to use our own, the one provided by Google, and you can see there's available a number of languages there to meet your developmental needs. The good thing about App Engine Flexible is that it enables you to extend beyond the capabilities of the included runtime. So what I mean here is if you're using PHP and you're doing your app dev in PHP, you may want to bring in some C libraries, and App Engine Flexible enables you to do that. So, excuse me. Additionally, we have App Engine Standard Runtime, which allows you to concentrate on your application development, but it's a bit more constrained. So you can't bring in those C libraries for PHP. And because it's more constrained, it enables you to scale and expand out that scale very rapidly. So it's very performant, in terms of addressing performance load on your application. And it will scale from 0 instances all the way up to, once again, whatever you need to fulfill your load. So if you're not doing anything, App Engine will wind all the way back to 0, so you're not paying for those services. The last one here is about Cloud Functions. So this is about serverless computing. And if App Engine was focused on an abstraction layer around an application, Cloud Functions is an abstraction around a particular function. So this is where you're not writing a complete application. All you're focusing on is a function capability. You want to deploy that in a scalable way. An example there might be I have an application that I've constructed, but I want to add the ability to that application to send an email. So rather than redeveloping that application to add email functionality, I might develop a Cloud Function that just does the email. I get an endpoint to call that Cloud Function, and from my application, I just trigger off that endpoint and I can send an email, right? So it provides an abstraction layer at a higher level. So that's computing, getting things done. So we've got virtual machines, we've got containers, and we've got some serverless computing around functions and App Engine. So networking is about how we connect things on the Google Cloud Platform. And really there's a couple of things here as well. How do we connect them? How do we secure those connections? And how do we make them available, or more highly available for our end users? There's a separate section later this week in the on-air webinar series to talk about security and securing your workload. So I'm not going to go into that in too much detail, but if you're interested, I encourage you to dial in and connect to that one. So let's talk about the first aspect there, connecting. So connecting to the cloud platform. The first one is a Google Cloud Virtual Network. So this is a custom private cloud network that you can construct, setting up custom routes internally within the Google Cloud Platform, but also externally as well. So it enables you to set up that network to meet your exact requirements. Similarly, Cloud Interconnect enables you to connect your on-premise systems in a very high-performant way to the Google Cloud Platform. So perhaps you've got a lot of data that you need to push back and forward to the Google Cloud Platform from on-prem into the cloud, and Google Cloud Interconnect enables you to do that very easily. From a security perspective, here we're really talking about the ability to establish virtual private networks. And this isn't the same virtual private network that you would give to perhaps one of your technical team traveling on the road when they're staying in a hotel. This is about virtual private networks between gateways or between services. Essentially, we can use any IPsec compliant gateway. You can construct them using IPsec, you'll come into the VPN and you have access to the services. From a security perspective, the other common element that you'll want to set up is firewall rules. So firewall is exactly that. It's a firewall that provides access for certain IP ranges and ports. You set up those rules, you can apply them to tags within your Compute Engine instances or within your Google Cloud Platform services. You can apply those tags to hosts, deploy the firewall, and it will function as you'd expect. Once again, you can set these up using command line interfaces or using the Google Cloud console. So what happens if I want to do some security stuff that we don't have on the Google Cloud Platform? There's no problem there either. So what you can do is you can instantiate a Compute Engine instance and build whatever you need on that instance itself. So maybe some custom solutions. Alternatively, you might go up to the Cloud Launcher and see if there's a product up there that you're looking at, and you can take that pattern and deploy it quite readily. So things like Barracuda or Cloudflare, and there's other ones up there as well. So go and have a look, and you can instantiate that on a Compute Engine instance, incorporate it into your overall project, and take advantage of that non-managed security that you need. From an availability perspective, we have the Content Delivery Network, and this is all about pushing data or making data more readily available at the edge of our network. So things like edge caching and preloading of those caches. And we can do that primarily we're activated through our load balancers based on HTTP headers. So we can provide that service. DNS, this is exactly what you'd expect. It's a DNS server running inside Google Cloud. Promises 100% SLA, which is really great, and enables you to add your own servers into that mix so we can find them. And similarly, load balancers, to distribute load, both from external sources coming into our platform and within the platform itself to distribute work amongst multiple services there. So all those services that would expect to be there are there. So we've talked about computing, getting things done. We've talked about networking, but often I have data that I need to store. And there's a separate session on data, so I'm going to cover this at a high level as well. So where do I keep things? So when you're keeping things, it's probably good to understand what kind of things you want to keep. So typically that may be files. So we might talk image files, video files, Office documents, PDF files, etc. Sometimes called object storage or blob storage. I may have some database needs. So I might want to store things in a relational database or potentially a NoSQL database. And then I have big data. So how do I do these three things? So from a file storage perspective, when we're talking about that object storage or that blob storage, we have Google Cloud Storage. It enables you to create a bucket, and then you write files and read files out of that bucket. And there are several types of buckets that we can set up: multi-regional, regional, nearline, and cold line. And depending on your requirements will depend on which one you should go with. And I'll go through those shortly. When I'm talking about those storage options, so multi-regional, regional, etc., it's good to understand not only the type of data I want to store, but who's going to access it. Is this data that's publicly available? In other words, publicly available globally, or is it data that I need to have close to my application that's processing that data, or is it a long-term storage type scenario where it might be a backup or an archive that no one's really going to look at day to day, but they might every 3 to 6 months look at that video file. So long-term storage. And based on your particular needs, you may go with something like multi-regional storage for public data, where you're distributing that across all our regions. So high availability, geo-redundancy, costs a little bit more than the other layers of storage, but it's great for those kind of use cases you can see on the slide there. Alternatively, if I need to maintain that data close to where I am, I might choose regional storage. And this is where it's held in a narrow geographical region, perhaps in Singapore, Tokyo, US, etc. It still can be split across zones within that region. Slightly less storage cost, depends on the need. And then the long-term storage is really based up into two options, nearline and cold line. And both of these are similar, They provide very fast access to the data, but it's at a lower storage rate. But when you access the data, we charge you a cost for retrieving. And there's minimum charges there as well. So 30-day minimums and 90-day minimums, depending on which level you go with there. That's not to say you can't delete the data within that time period. You can. It's just that we're going to bill you for 30 days or 90 days, depending on which one you choose. So application data, this is where we start getting into that almost religious debate around SQL or relational databases and NoSQL databases. I'm not going to buy into that debate today. All I'm going to say is that we can do both. So on the Google Cloud Platform, we have Cloud SQL. And this is a traditional SQL server, relational database, that can run in the cloud. Vertically scalable. We manage the backups for you. It's easy to set up replicas if we need to. And we support two types, essentially, at this stage. So MySQL and Postgres. So if you have a relational database need, Cloud SQL is there to help you. You may have also heard about a new one called Cloud Spanner, which we announced earlier this year. So Cloud Spanner, once again, is based off a research paper coming out of our engineering team, but it provides you a globally distributed, horizontally scalable relational database system that provides high availability and strongly consistent transactions. There's a separate session this week to drill into Cloud Spanner because this is quite unique, quite a unique technology. So I encourage you to dial into the Spanner talk later in the week to learn more about that one. So NoSQL. So we've got a couple of flavors of NoSQL databases that we can use and leverage. The first one is Cloud Data Store. It's document-based, it's indexable, it enables you to scale, right? So we have a lot of organizations, a lot of gaming companies are using this to store user data, to store artifact data. It scales globally, very fast, very performant. So Cloud Data Store is there as well. Now, on top of that, we have Cloud Bigtable. It's a columnar, low latency, NoSQL database. It's very similar to HBase from an API perspective, and it scales kind of a bit more than what Data Store can, above the terabyte type level. So there's our storage. The last one, we've talked about file storage, object storage, data storage inside SQL and NoSQL. The last topic here is around big data. So really, where do I store my big data? I can store it in any one of those options. So I could store big data in a file storage, object storage location. I could store it in SQL. I could store it in one of my NoSQL tables. What's more important is what I can do with it on the Google Cloud Platform. To that end, we have a number of services that are available to help you access that information, analyze it, and do stuff with it. The first one I'm going to talk about is BigQuery. So BigQuery is a data analytics warehouse that enables you to pipe data into it and then run some analytics very quickly against it. So when you're doing big data analytics on premise, typically you set up some kind of cluster of servers. You have a query and you throw all your computing resources at that query, and the query will finish whenever. For Google Cloud Platform, and in the case of BigQuery, this is Google's infrastructure that we're throwing at it. So it's very fast, very performant, and enables you to analyze large volumes of data very quickly. So we're talking about billions of rows within seconds type response. One of my colleagues regularly does demonstrations showing queries against a petabyte database, so 1 trillion rows, and he's getting response times in about the 3 to 4 minute period. So this is a tool that enables you to analyze data very quickly using standard SQL. So some of the other tools that we have available to help you on that big data journey. The first one here is Cloud PubSub. So this is a messaging bus that enables you to push data into a topic and pull data from a topic and then process it. It's very scalable. It will scale up to, actually it will scale beyond 1 million messages per second. But we ask if you're going over 1 million, just let us know. Just set a flag and say, hey, I'm going to go up to 2 million. I'm just letting you know, right? So this is a very performant messaging bus. So often when you push data into a topic in PubSub, you want to pull that data off and do something with it. You want to transform that data and take it from the source and put it into a sink somewhere. And that's what Cloud Dataflow provides you with, the ability to transform data from a source into a destination. It's based on Apache Beam. So this is a managed Apache Beam instance, Google Cloud Dataflow, enabling you to define the transformations you want to occur on a particular data set and run that and manage it for you. And the last one here is Google Cloud Dataproc. So this is essentially a managed Hadoop Spark instance on the Google Cloud Platform. So its ability to instantiate a Hadoop Spark cluster very quickly, often within 90 seconds, define those nodes, we manage it for you, and it provides you with a very fast way of getting into that kind of Hadoop Spark, Hive, Pig type environment. It will auto scale based on your parameters, very performant, very effective. Now, importantly, all of our services have an SDK and an API layer around them. So you can write programmatically to interface with each service individually. But often we will look for a way to loosely couple these services. And Google Cloud PubSub and Google Cloud Storage is something that all these services have in common. They can all write to a topic, pull from a topic, and write to storage. So often we see solutions where services are being tied together using Cloud PubSub or Google Cloud Storage. The example here is that you might receive an image from an application. That image might get written to Cloud Storage, which might trigger a Cloud function to go and retrieve the image, run it through the machine learning API, and do some analysis. So you can tie these services together very easily. So what if I need something that we don't offer on the Google Cloud Platform? No problem. You can use Compute Engine and build what you need. Alternatively, you could go out to Cloud Launcher and see if there's a pattern out there that can help jumpstart that. So maybe something like Cassandra or MongoDB or others, right? So you can go out and have a look at the Cloud Launcher, bring that in, incorporate that instance as part of your overall solution to fulfill your specific needs. Okay, so we're going to talk quickly about administration here and operations. So from an administrative perspective, there's three things once again. So reporting, security, and configuration. So from a reporting perspective, we have a capability called Stackdriver. So Stackdriver provides a Google Cloud logging. It's a logging service. So it's going to keep track of all the Google Cloud Platform service logs, but it also enables you to keep track of logs from things like AWS or even your on-premise solutions as well. So you can bring those together and get a unified view across those logs and that information there. Similarly, Stackdriver monitoring provides the capability to look at Google Cloud Platform, AWS, etc., and trigger alerts based off things that are happening in those systems. So whether it's a log or some kind of uptime, a server's gone down, or there's some kind of metric that you've built around that. So we've got Stackdriver logging and Stackdriver monitoring. From a security perspective, we have Cloud IAM. I can't even say it this afternoon. Cloud Identity Access Manager, which enables you to define users and groups and provide those users and groups with access to particular services within the Google Cloud Platform. So role-based, very fine-grained, and it depends on the service, but you can get very detailed into the granular level you're going to here. So it enables you to lock down your service very well. And as I mentioned, there's a session later on about locking down and securing your workloads. From a configuration perspective, so how do I deal with and configure Google Cloud Platform? So there is a browser interface called the Google Cloud Console, but often people like to configure things using the command line interface. So there is an SDK that enables the command line interface. So gCloud and the Google Storage utility enable you to write scripts and to customize that side of things. Alternative, there is that API layer which provides a RESTful API across our services, and it's functionally equivalent to the Google Cloud command line prompt. So it enables you to programmatically interface with the Google Cloud Platform system and services. And the last one is Deployment Manager. So Deployment Manager enables you to define, from a script perspective, from using YAML, complex deployments, treat them as a system, maybe store them in your repository, deploy them to other instances, and spin things up more readily and a little bit faster. So Deployment Manager. Okay, so development. So a lot of our services are about enabling developers to focus on their applications, on the functions they need to do their jobs. So from a development perspective, we're talking here about coding, reporting, and the services that are available to those developers. So I've mentioned we have our SDKs, we have our Google Cloud SDK, we have our Google Storage SDK using Google Storage Utility. And if you're doing application development using App Engine, then you may want to also use the app config utility, which enables you to interface with the application engine in a little bit more detail. We have plugins that will plug into the IDE of your choice, so IntelliJ, Eclipse, etc., Android Studio, Visual Studio. So it enables our developers to work in the environment that they want, but still have access to the Google Cloud Platform under the covers. And we have a cloud source repository, so any code you develop, can be stored up on that repository as well. So from a reporting perspective and development, we have some other Stackdriver tools. So Stackdriver Trace, providing trace across those services, so App Engine, load balancers, and it's embedded into the SDK that those users or developers are using. Similarly, we have error reporting there, which can aggregate those errors, provide from logs or API functions, and provide alerts based on those. And the last one is Stackdriver debugging, which enables the developers to actually step into code that's running on the platform and look at what's going on within that from both App Engine perspective and Compute Engine perspective. So there's a lot of tools there from a developer's perspective that's going to make things a bit easier. More importantly, when we look at Google, it's more than just Google Cloud. We have services around YouTube, we have services around Android, services around Maps, etc. And these all integrate very nicely into the Google Cloud Platform infrastructure to the point where we can use default credentials within Google Cloud to call out very easily into these other services and get things done. So it simplifies the process of integrating with other Google services that are available. So the last topic here is around machine learning. So machine learning is once again really three things. It's about using models, it's about creating models and extending those models to meet our particular need. So from a Google Cloud Platform perspective, we have a number of models that we have developed and trained, and we've surfaced those through the APIs in machine learning on the Google Cloud Platform. So we have the Vision API, the Natural Language API, Speech API, and the Translation API, enabling you to interact with vision, speech, etc., translation. So doing things like on an image, we may want to detect faces, we may want to extract text, we may want to take that text and maybe run it through the Natural Language API to get sentiment or syntax analysis or entity extraction. We may have an audio file that we want to convert to text, Speech API. We have a Translation API, we might have something in Japanese, we want to convert it to English. So these are APIs that you can use in your own applications very easily. And I encourage you, if you haven't started playing with them, to give them a go. Sign on to the Google Cloud Platform, start playing with these APIs and seeing what they can do with your data. But sometimes we want to extend that and build our own custom models from a machine learning perspective. And that's really where Cloud ML Engine comes in. So the Cloud ML Engine is a managed TensorFlow instance. So that begs the question, what flow? Right, so TensorFlow is another one of those research projects from Google Engineering, which we've open sourced as TensorFlow. You can grab TensorFlow from GitHub, bring it down and use it on premise, and enables you to build your own models based on your own data needs. When you're building these models though, although you can do it on your laptop, you're sometimes at the mercy of the compute power available on that laptop, particularly if you've got complex models and large data sets. And that's really where Cloud ML Engine comes in. It's managed TensorFlow up on the Google Cloud Platform. We can take your models, we can take your data, and it scales very well on and generates models very quickly using things like graphical processing units to do that. And then you can use that model as you need to within your own applications. So as I mentioned, there's a lot of stuff in the Google Cloud Platform, and when you look at this big blue hexagon slide, sometimes a little bit daunting, but hopefully what I've just gone through simplifies that a little bit for you and provides you, with enough confidence to start exploring Google Cloud Platform and what it can do for your business. So thank you for joining me this afternoon. There are a couple of steps, some things you can do if you want to learn more. Obviously, the first one is to make sure you've registered for the other on-air webinars this week. But you can go and get certified. Google Cloud or cloud.google.com/training provides some certification links and some training links up there. You can go to Quick Labs and get some labs and do some tutorials on the various elements that make up the cloud platform. You can sign on to Coursera and run through some courses around maybe DevOps or Compute Engine or maybe machine learning. Or you can contact us. If you're in Australia, New Zealand, contact the local team here. If you're elsewhere in the region, contact your local representatives, and we'll come out and have a chat to you about any of this and drill down as I mentioned. Importantly, if you sign up to Google Cloud, there's a free trial. You have a bucket of funds available that allows you to explore, maybe run those tutorials, try things out with your own data, and start the journey. I'll be back with Hilary O'Connor, who's my colleague here in Australia, and we're going to address some of the questions that may have been raised while I've been talking. So we probably need a minute or so, and we'll be back then. Thanks. So thanks for joining us again. Hopefully it wasn't that long for you. I have with me Hilary O'Connor, who is another customer engineer within the Google Cloud team in Australia and New Zealand.
Hey everyone.
Hilary's not based in Sydney. Hilary's over in New Zealand. You might be able to tell that from the accent, but we're fortunate to have her with us today. So Hilary, you've got some questions?
Yeah, I have a few questions that have come up, so we'll get into them. So firstly, can GCP or Google Cloud Platform be integrated with someone's existing on-premises data center?
Yeah, so there's a number of ways we can do that. I mentioned earlier that there was the Cloud Interconnect, which enables you to establish a pipe, if you like, so you can push data back and forward. There's, from a networking perspective, we can certainly create routes that will route work where it needs to go.
Great.
So I guess the answer is yes.
Absolutely.
Easily. Do you have anything to add to that?
I'd add a couple of things, maybe around the VPN. So I believe you talked about the IPsec gateways earlier on, and how we can, if you have an IPsec gateway, you can connect to us and have that private connection through a VPN. And also, if you're looking at running containers, so Kubernetes and some of the other things that you talked about, then you can actually manage those across both an on-premises and cloud workload as well. In fact, even cloud to cloud if you want to be on the edge.
Yeah. So we're seeing that quite a bit from a managed Kubernetes and a multi-cloud solution where we have containers deployed across cloud vendors and on-premise to provide a even more highly available solution.
Absolutely.
Yeah, so some really cool things around that. So I've got a question for you, Hilary. I'm the second one here. What are some of the main differences between Google and AWS?
Sure, there's quite a few, so we'll just focus on a couple of them. I guess one of my personal favourite ones is the ability to have custom machine types. So instead of having to have the t-shirt sizes where you have to go, this vendor is giving me the option to have this amount of CPU and this amount of RAM. Maybe I want this amount of CPU and this amount of RAM, or vice versa, but I have to pay for both. Well, we give you the option to have these custom machine types, which lets you say, this is the amount of CPU I want, this is the amount of RAM I want. And if you can imagine, if you're spreading that out over a whole lot of different machines, then from a cost perspective, you can actually save some real money if you're building it out over a fleet of other machines. If you're dealing with load balancing, I know you touched on that earlier, and if you've got spiky traffic loads, with us, you don't need to pre-warm the load balancers. So once that spiky traffic hits, the load balancers are going to kick in, and there's no waiting around for other vendors perhaps that may need to pre-warm those load balancers for you. On the topic of load balancers, we also give you a global IP address. So rather than having to have, say, a region by region IP address and then do DNS round robining, you can have a single Anycast IP address with us as well. There's quite a few other things that sort of go into the pricing aspects as well, but we don't have to drill on those today. But if you head over to the website, we've got some great, in fact, there's a great series of documentation that I recommend whoever asks this question takes a look at, called GCP for AWS professionals. So Google search that and it will give you some great links and help you understand what we do and how it differs to what AWS does. The
other thing, Hilary, that I'd encourage people to do is to, if you're familiar with AWS, familiar with starting Compute Engine, familiar with maybe deploying Hadoop and having, kind of a data processing environment on AWS, I'd encourage you to sign up for our trial, use your $300 credit, start playing with some instances, see how quickly those services come up, and I think you'll be a convert. Yeah.
Actually, one last thing I'll throw in, just because you mentioned about quick and speed and services. One other great feature differentiator we have is around live migration. So the ability that if we need to do maintenance on the VMs, we live migrate those for you so you don't have any downtime. There's no kind of more having to plan around another vendor's scheduled maintenance where you have to that becomes your problem. or the machines get shut down, we live migrate for you. So it's another great feature.
There's some cool things there. So check out the website. There's some great stuff up there to have a look at. But, sign up for the trial, get into the Google Cloud platform, start experiencing it for yourself, see what's possible, see how fast it runs. And as I said, I think you'll be a convert.
There's a couple of other questions.
Go ahead.
Great. So someone had lots of on-premise VMs. How do they work out what they want to move?
Good question. So we've got lots of VMs running on premise at the moment. How do we take, which applications do I move across? And I guess the first point is to understand what those applications are at a deeper level. So try and do some triage around the impact or the load, the data, etc., that's required for each of those application stacks. Some of them might be relatively easy to move, where they don't have dependencies on other on-premise solutions, on-premise data stores. So you might be able to move those quite easily.
Great.
Some of them might have some more dependencies, which you may want to give some more thought around. And some, maybe they've got to stay on-premise. So we look at maybe a hybrid solution, as we talked earlier. But the important thing here is that there are tools available to help migrate those across from on-premise into the cloud environment. We can do that live migration, so it's running on-premise and you want to move it to the cloud. We can do the live migration. It will start pushing up into the cloud environment, into Google Cloud. Once it's there, you're notified and you can start one and stop the other and repoint, etc. So
I'd recommend that people have a look at Cloud Endure. So Cloud Endure is a service that we partner with at Google, and we take care of all of the pesky pricing and all of that for you. We do it all for you. And that does exactly what Malcolm was just talking about. So that lets you live migrate from both on-premise and virtual machines and other cloud vendors. So have a look at Cloud Endure.
So just to recap, that's that question. Look at the workloads, try and do some triage. It's about dependencies, data storage, etc., and what would be low risk and relatively easy to move. Start with those workloads, get them in the cloud, start them happening, and then move to more tricky ones, which might require some, rejigging a little bit to make use of, the cloud capabilities.
Fabulous. There was one last question.
Sure.
The organisation's concerned about data security and the cloud. So if they were going to move to a cloud-based solution, how can they ensure their data is encrypted?
So this is a good question. We've got another session later this week to talk about securing workloads. So I'm going to, remind you all the time, every time I get to tune in for that one. But essentially, at a very basic level, security is probably more important to Google than it is to any other organisation, right? So security is very important to us. We have a whole team, I think it's about 700, 800 engineers focusing just on security aspects around Google Cloud. But at its function, at the base function, when we're talking about data and moving into the cloud and working with cloud-provided solutions, we're really talking here about encryption in transit and at rest. We use a number of algorithms to ensure that. Using user key encryption, either keys that we generate internally or ones that the user provides, the customer provides, so we can't even access that data if we wanted to. Security is very important. If you're moving to it, you can ensure your data is encrypted. We provide that service by default. It's turned on.
Fabulous.
Anything else to add there, Hills?
No, I think that was great. I mean, you touched on it, but we did recently release our cloud-managed KMS that allows us to manage your keys on your behalf. So all the rotation and those sorts of things of the keys we do for you, but we still have no access to those keys and thus your data.
And as I mentioned, Liam Tong, who is another one of our colleagues here in Sydney, he's our technical program manager in the professional services organisation here. He's got a complete session, on-air session later this week on securing your workload. He's going to drill down into a little bit more detail around the algorithms and particular security elements.
Great. Well, that's all the questions that we had.
So with that in mind, thank you once again for joining us today. It's been our pleasure to host you this afternoon and to address some of these questions. Next steps from your perspective, get certified, have a look at the training links, start playing with the Quick Labs, look at the Coursera courses. And as I mentioned just then, sign up for the free trial. Start looking at the services, particularly around Compute Engine, particularly around big data, see the capabilities that we provide, and start that journey. So thanks once again for joining us today, and we look forward to you dialing in and connecting to other sessions this week. Cheers.